for you. I mean, the reason we did that. Anyways, let's leave that for some other times. I just started the recording. So today we are talking about chapter 20, and that is about oxidation and reduction reactions. We already talked about oxidation, especially of organic compounds, when we discussed chapter 23 last semester. And we showed you that how the increase in the oxygen content or the decrease in the hydrogen content is the form of oxidation. Of course, the opposite of that will be reduction. But today we're going to look at it from a different perspective, which is other than the oxygen. So what we are discussing today is the meaning of oxidation and reduction. That's what we will do. So the first objective will be to describe what happens to a substance that undergoes oxidation and the one that undergoes reduction. As I said, from previous knowledge, we know that an increase in the oxygen content or decrease in the hydrogen content is the oxidation as we know it before. But that is only for organic compounds when we have oxygen and hydrogen. But sometimes we have metals that they react with each other, and some of them they undergo oxidation and reduction. So there will be a new definition or an added information, and that is regarding the loss or gain of electrons. Loss of electrons is going to be oxidation, and gain of electrons will be reduction. That's the bottom line of the first objective. Then in the second one, that is very, it's kind of an application of the oxidation and reduction, which is explain how the presence of salts and acid accelerate the corrosion of metals. Metals like iron and some other metals, they corroded whenever there's oxygen in a humid situation where water is present. That will be faster, but also it will be faster even more when we have salts and acids. We're going to see that as an application and see why it is increasing the oxidation and reduction. طيب, this is a good question here, and that is again apply to other countries, not in here because we don't have snow, we don't have anything. Why do you need to wash the bottom of your car? I mean, we do wash it here, but we wash it from sand. But in winter cold climates, usually you have to wash it in order to remove the salts that are stuck in the bottom. And these salts are coming from the roads because during the snow season, they put a lot of salts in there, and that is based on the hot pack that we talked about last time. That is an exothermic reaction. The dissolution of salts in water will produce heat, and that's why they use the salts in that case. So when you drive in a snow climate kind of thing, then a lot of salts will be stuck in the bottom of your car. If you don't remove it, then that will result in corroding your car. That's what will happen. One of the things, well, let's move on. I mean, I have a story to tell you, but I decided not to. Okay, so what happened to a substance that undergoes oxidation? This is the question that we need to ask and answer. What happens to the substance that undergoes reduction? That is what exactly we need to discuss. Why this is not moving now? كل يوم في مشكلة في هالسكرين. I don't know why. It moves. طيب نرجع لورا. يا الله. Okay, so one of the oxidation reactions that we discussed several times is the combustion of gasoline. When we put gasoline in our cars and we run our engines, what happens is the burning reaction happen inside, and that is a reaction of the organic compound, which is gasoline, with oxygen. So also the same thing happened in your body when you take food. The way you produce energy is by burning that food with oxygen also in the in your cells. So both reactions, whether in the car or inside the car or inside the human body or any living body, then what happens is that the reaction with oxygen is basically producing the heat and the energy. So and outside also, when we cook at home, what we do is we burn the methane or butane gas, and that is with reaction with oxygen. So methane gas reacts with O2 to produce carbon dioxide and water. That is a general reaction for any organic material, anything that has or hydrocarbons. When oxidized, they react with oxygen to produce carbon dioxide. So if you look at the at this one here, if you compare between methane and carbon dioxide, so the carbon here, the oxygen content has increased and the carbon hydrogen content has decreased. So that is another way of looking at the oxidation. Previously we discussed that. Now every time we need to move this one. Okay, it's shifted, that's why. هيك backward. والله اليوم شكلها الامور مش ماشيه صح. طيب. So is it necessarily that we have to burn something when we react it with oxygen? Not necessarily. So if you compare the iron here, which is just fresh iron, and then we leave it outside with the humid weather, then it reacts with oxygen to produce this brownish kind of rusting material. So rusting of iron is an oxidation reaction, which is the reaction of oxygen with iron to produce iron oxide. And that is, there's no burning here, and there's no carbon and hydrogen. So oxidation doesn't mean always burning. The second thing, it doesn't mean that we have to have always carbon and hydrogen and look at the reduction or increase in the hydrogen content. So we have metals that are reacting with oxygen to produce oxides. Also, one other reaction that has an oxidation is the bleach, the Clorox that you guys use at home. The reason we use Clorox because it oxidizes the stains of the colors. Yeah, that's why إذا تحطوا على شيء colored, it will remove the color. That is also an oxidation. In addition to using hydrogen peroxides in the places where you want it to be cleaned from bacteria, that is killing bacteria this way is also by oxidation. So hydrogen peroxide oxidized the bacteria. The process that called reduction is exactly the opposite of oxidation. So we cannot have an oxidation without having a reduction. If the oxygen content has increased, then it has to decrease somewhere else. If the hydrogen content decrease or increase, then the opposite will happen. So reduction meant the loss of oxygen from a compound. For example, if you consider iron oxide, the way they produce iron, they manufacture iron. Actually, they take the what they call the iron ore and the which is iron oxide, react it with carbon. Now that will produce iron and carbon dioxide. So as you can see here, that the iron has lost the oxygen, and the carbon has gained the oxygen. So that's why the carbon is oxidized, and the iron in this case is being reduced. So every time you have an oxidation, there must be a reduction along with that. But in addition to that, since they are the opposite, so losing oxygen or gaining hydrogen also is a form of reduction. So iron oxide is reduced and the carbon is oxidized in this case. Oxidation and reduction always occur simultaneously. That is the conclusion here. Is that always, whenever you have an oxidation, you must have a reduction at the same time. But a substance that undergoes oxidation basically gains oxygen. So that is partially answering our question, which is what happened to the material that undergoes oxidation? It is the one which is gaining oxygen. A substance that undergoes reduction loses oxygen. No oxidation occurs without reduction, and that is also, we already stated that. Then the type of reaction that we talk about here, they call it oxidation reduction reaction, because every time there is an oxidation must be a reduction. So the whole type of reaction is called oxidation reduction reaction, or sometimes they use an abbreviation which is redox reaction. So redox reaction or oxidation reduction reaction means the same thing. There's something that is gaining oxygen and some other material are losing that oxygen. So oxygen transferred from one element into another. One of them is increasing their oxygen content, the other one is decreasing, that is a reduction. Right. Then that was not limited to this. The oxidation concept and the reduction concept has been extended further by involving electrons in there. So it's not only about the, it's about the oxygen content, but also about shifting of electrons. And that is gaining or losing electron partially or completely. That's what we're going to see today, which is how it is partially or complete. So oxidation now is defined as the complete or partial loss of electrons. Now, what is the meaning of partial? Yani shifting of electron without completely transferring. We will show you that. That is polar bonds. Whenever you have a polar bond, if you still remember what a polar bond means, when you have two different electronegative atoms, then you will see that they are, the electrons will be shifted toward the most electronegative one. And that is the meaning of a partial loss. Complete loss, of course, that is the complete transfer of electrons. So a reduction, since it is the opposite of that, it will be defined as the complete or partial gain of electrons. So if we gain electrons, this means that we have reduction, and if we have loss electrons, then that is an oxidation. So if you look at these two triangles here, oxidation, loss of electrons, gain of oxygen. So now we have the two items together, either this or that, or sometimes it happens both of them. Losses of electron or loss of electron, gain of oxygen, gain of electrons, loss of oxygen is the opposite for reduction in this case. No way I can move the slides from the screen. I have to go back to the computer every time I want to move. Right. Let's take an example to see how the reaction of metals with non-metals. That has already been discussed, but when we discussed it before, we were just looking at what we call formation of ionic compounds, and that is by transfer of electrons, not sharing electrons. So when we form an ionic bond, that is happening by transfer of electrons. As you know, one of them is losing electron, the other one is gaining that electron. And by having a positive and negative charges, then the attraction will happen and we form ionic compounds. Now, we're going to take a look at that kind of reaction, but from a different perspective, which is gaining and loss of electrons. The same thing. So the metals that are in the left-hand side of the periodic table, they tend to lose electron to form cations. And the one in the non-metals, they tend to gain electrons and they form anions. And so we can form something like magnesium sulfide, for example, as you can see in here. So the magnesium metal is heated with the non-metal sulfur, the ionic compound magnesium sulfide is produced. Now, when this happened here, the magnesium is the one which is losing electrons. So we can say that magnesium has been oxidized and sulfur has been reduced by gaining the electrons. So as I said, we're going to look at it from a different perspective now. So magnesium will lose the 2 electrons to the sulfur and the sulfur will gain them. That will produce Mg2 plus and sulfur minus 2. Why it is minus 2? Because it gains 2 electrons. Why this is plus 2? Because it lost 2 electrons. But if you look at it from away from being cations and anions, one of them has lost electrons and the other one has gained it. So there is a gain and loss of electrons. So sulfur is the one which gaining electrons and that is reduced. And magnesium is the one which is losing electron and that is oxidized. So we can say clearly that magnesium has been oxidized into magnesium ion and the sulfur has been reduced into the sulfide ion. But this is with negative and the other one with positive. This is the way we can write what we call half reactions, which is showing the electrons in the equation. The oxidation is basically magnesium to magnesium plus two electrons. These are 2 electrons. When they are in the product side, then they are lost. So that is an oxidation. And gaining electrons is going to be the 2 electrons, same 2 electrons that are produced, they are gained by the sulfur to form the sulfide ion. So if you add these 2 equations together, the electrons will cancel with each other, and you're going to end up with the same equation that's in the top. Right. Now, we're going to introduce something, after answering the question, that is substance that undergoes oxidation loses electrons, and substance that undergoes reduction gains electrons. So far we know 2 things about oxidation and reduction. The first thing, or to answer the same question, what happened to the material that undergoes oxidation? It is the one which is gaining oxygen or losing electrons. The one which undergoes reduction is the one which loses oxygen or gaining electrons. Now, what causes this? Why the one which is oxidized being oxidized, and why the one which is reduced is being reduced? Because oxidation and reduction, they happen at the same time. So the one which is causing the other material to get reduced, which is oxidized, we call it reducing agent. And the one which is getting reduced but getting the other material oxidized, we call it oxidizing agent. So the material that is oxidized is the one which we call reducing agent, because it caused the other material to get reduced. And the one which undergoes reduction, we call it oxidizing agent, because it's causing the other material to get reduced. So now we have, in any oxidation reduction reaction, we can determine which material has been oxidized, which material has been reduced. And of course, once we determine that, then we can decide which one is reducing agent and oxidizing agent at the same time. So in this case, which is the magnesium sulfide compound, magnesium has been oxidized. So that is the one which is a reducing agent. And the sulfur is called oxidizing agent because it's been reduced. So for that reason, we can take an example of this example in front of you, which is silver nitrate reacts with copper. Here we have the silver nitrate reacts with copper to produce copper nitrate and silver metal precipitates. If you want to ask you, what type of reaction is this? What type of reaction? It is an oxidation reduction reaction, but the major 5 types of reaction that we have discussed before. Double replacement ولا single replacement? double ليش وين الدبل؟ It's a single replacement. The copper taking the place of the silver. Okay, so anyways, let's take a look at the as per the question here, from the equation below, determine what is oxidized, what is being reduced, and which is the oxidizing agent and which is the reducing agent. In order to answer such a question, the best thing is to write it in the ionic forms. If you write it in ionic form, this means that Ag here will be Ag plus, NO3 minus, this is 0. Then copper here is 2 plus, and silver here is 0. So if you take a look at the silver, then it was +1 and became 0. In order for that to happen, this means that it is gaining electrons. So silver in that case is the one which is getting reduced. And the copper was, with 0 charge, it became 2 plus. And that is what we call oxidation, because it has lost electrons. Why we have 2 silver? This will produce 2 electrons. Needs 2 electrons, and these 2 electrons are coming from the copper. Which one is the reducing agent? In that case, it's going to be the copper. And the silver is the one which is the screen اليوم ما فيها مشكلة. طيب. Okay, so identify the ions. That's what we do, as we did here. Just write it in the ionic form, and then you will understand that the reaction 2 electrons are lost from the copper, when it becomes copper 2 plus, and the same 2 electrons are used in. So we can write these 2 half reactions, which is copper is going to copper 2 plus, plus 2 electrons. That's why it is oxidation, and reduction is the gaining of electrons by the silver to form the silver metal, and that's why we can call the copper is the reducing agent and silver is the oxidizing agent. Type. Some reactions does not involve the formation of ionic compound, but rather it is the formation of a covalent bond. So how can we explain the oxidation and reduction when we are having or when we are forming a covalent bond? It is when we define the oxidation, we said partial or complete. Now, the one example that we just discussed with the silver and magnesium and copper and sulfur, it is between metals and non-metals where the electrons are completely transferred. While here, when we react hydrogen with oxygen, basically we are sharing the electrons. But the electrons definitely will be shifted toward one of them because this is a polar bond. Let me just show you how it will look like. So when we have the hydrogen alone, over here, that is, the electrons were shared 100%, so there is no transfer of electrons. But when we form the water, then you will notice that the hydrogen is the one which is losing the electrons. So the electron of the hydrogen is shifted more toward the oxygen because of the polarity. So that will make the hydrogen is the one which is losing electron. That's why it is oxidized. And the oxygen, on the other hand, is the one which is gaining the electrons partially, and that's why it is the one which is getting reduced. So the oxygen is an oxidizing agent. By default, it has to be oxidizing agent. Even if you think from other ways, oxygen always has to get reduced, not to be oxidized, and the other material as the one. What about if we do this? Okay, it moves. All right, so oxygen, on the other hand, is the one which is gaining the electrons by partially shifting them toward the oxygen, and that's why oxygen is thus reduced because it undergoes partial gain of electrons. Hydrogen is the reducing agent because it is oxidized. Oxygen is the oxidizing agent because it is reduced. So that summarizes the whole thing in this table. If you want to understand what is the meaning of oxidation and reduction comparing with each other. The first one is the complete loss of electrons. That is oxidation, and that happens in the ionic reaction whenever we form ionic compounds. The same thing with the reduction is when we form a compound, it is a complete gain of electrons. If we are forming covalent bond, then that is just a shift in the electrons. It will not happen whenever we are forming something with non-polar bonds, but whenever we are forming covalent polar bond, then in that case, it is a partial shift of electrons. And oxidation in that case is away from the atom, and shift of electrons toward the atom, that is the reduction. The third one is something that you know from before, which is gaining electron, oxygen, losing oxygen, and also loss of hydrogen by a covalent compound and gain of hydrogen. That is something that we have discussed when we have the organic compounds. Like even in the case of burning methane, the carbon is gaining oxygen, but also it is losing hydrogen. It was CH4 became CO2. There's no hydrogen in there. So, or when you're forming alkenes from alkanes, for example, you're removing 2 hydrogens. So that is a reduction, even without oxygen being involved in there. Now, the one in red is the one which will be discussed next section, which is we're going to determine what is we call oxidation number for the atoms. And based on the oxidation number change, we can decide if it is oxidation or reduction. Increase in the oxidation number, that is an oxidation, and decrease in the oxidation number is reduction. So that is the to be discussed in the coming section, inshallah, section 2. All right, so do we know now, or do we have an answer to our question? What happened to the substance that undergoes oxidation? Either it is complete loss of electrons, partial loss of electrons, gain of oxygen, or loss of hydrogen. or later on, it is an increase of oxidation. The opposite happens in the case of the material that undergoes reduction. So we have answered the question in that case. Type. The element that donate electrons in a redox reaction is called the reducing agent. Which of the following is always true of the reducing agent? It is oxidized, right, or reduced, or it is ionic, or it is covalent. أيها الشعب النائم يا جماعة الزوم. يعني this is an easy question. Okay. بس اثنين اللي معانا. مين كمان؟ Okay. طيب كويس. At least you guys are awake. I know that you have biochemistry exam today and won't blame you sometimes. طيب, it is oxidized. That's what it is. It is about application. So that corrosion is basically, or rusting reaction sometimes, rusting of iron, corrosion for other metals, but the question is why it is getting accelerated with salts and the presence of acids. Simply because, I can tell you the answer from now, is that we're talking about loss or gain of electrons. How the electrons will move usually. They will move in solution. They don't move in the air. Right? يعني مش بيطيروا الالكترونات from this one, they fly to one metal. They move through the solution. So as long as the solution is electrolyte, يعني it can conduct electricity, then the electrons will move faster. If that is non-electrolyte, then they will move slower. So having a salt in there or acids, both of them, they are ionizers into plus and minus charges, and that will produce what we call electrolyte. Whether strong or weak, that's a different story. But the presence of salts or the presence of acids in solution will make the oxidation and reduction faster, and that is what we are referring to as corrosion. So corrosion is basically an oxidation reaction, and that will happen faster because when we have the salts and we have so water in the environment accelerate the rate of corrosion. We know that is the same in order to make a media for the transfer, just water as it is. Now, if you have water with salts and acid dissolved in it, that will make it even better. So the original one is having the water will accelerate the corrosion, but the one which is more is the presence of salts. Here's the corrosion of iron or rusting of iron. Iron is reacting with oxygen in the presence of water to produce iron hydroxide, but then that iron hydroxide will react further with oxygen to further oxidize. Because if you look at the charge over here on the iron, that's +2 because we have 2 over there. But if you look at this one, that's a 3. So originally we have the iron as a metal, so this is iron 0, and then we moved it to iron 2, but we can oxidize it further into iron 3, and all of that is accelerated with the presence of water. So corrosion occurs more rapidly in the presence of salts and acid, because that will make this job much more easier, because transfer of electrons. Okay, so the presence of salts and acids accelerate the corrosion by producing a conductive solution, that is make the electron transfer easier. That is the main story in this corrosion, how it is accelerated. That's why we have to clean the bottom of our cars, because if you leave it without cleaning, then what will happen is that it will get corroded, and you'll have problems with the bottom of your car. If your car is exposed to salt in the roads in the winter, why it is important to wash it? Because you need to remove the salts from the bottom. Otherwise, the rusting will go faster, and that will create problems. Okay. Right. Sometimes even oxidation is favorable, and some people, they would like to see things oxidized from like these buildings. I mean, we don't have buildings over here that is made from copper, but that is very popular in Europe and in the US and the foreign countries. They do have some of parts of the building that is made from copper, and that is will get oxidized. The oxidized copper, the color of it looks very nice. They call it the patina, and that is the pale green color that is resulting from the copper to carbonate, and that is resulting from the corrosion of the copper. That's an example on that. Gold and platinum, they are noble metals. They don't corrode. Otherwise, we're going to lose our gold. And they don't corrode. Very resistant to losing their electrons by corrosion. Losing electron is easy, but protected from extensive corrosion by oxide coating formed in their surfaces. So other metals, for gold and platinum, they don't corrode at all. Some other metals which is not oxidized, like aluminum, for example. How come if we have, the windows are made from iron, if we don't paint them, then they will get corroded. But aluminum, even with or without painting, is not corroded. Why? Because when they are first, get in touch of oxygen, they form a layer of the oxides of that material that protect them. While in the case of iron, doesn't. I will show you a picture of that. Just bear with me. Where's the next? Okay, here what I'm talking about. This is the oxidation of iron. When the iron is getting oxidized, it is forming this kind of a film that is the iron oxide, but it is not completely packed. So there is some holes in there where the water can penetrate and do more and more oxidation. So even with this thick of iron, you're going to see that the penetration will happen, and if you leave it for a couple of months, then it will be gone. While the aluminum, on the other hand, what will happen is that aluminum get oxidized immediately and form aluminum oxide film that is covering the whole surface. Then after that, water cannot penetrate, oxygen cannot penetrate, so that's why aluminum is protected this way. So the difference, we have three types of metal: iron, which is getting rusted, and the iron oxide film is not protected. We have something like that, and we have the gold and platinum that is resistant completely to corrosion. In some, what we need to do in order to protect other metals from that, we have to do a couple of things, either by painting them, which is putting some painting film that protects them from being in touch with oxygen and water, or we can, what they call it, plate them. Plate them means to, electrically plate them or coat them with other metals that is resistance. We will show you some of those in a minute. So prevent corrosion of the metals either by oil, anything that can prevent the contact with the air and the water, paint, plastic, or another metal that is resistant. And one of the things that you guys know is, this is a bridge that has been, this is the Golden Gate Bridge in San Francisco. It's a huge, the biggest bridge in the world, and they are painting it, as you can see, in order to protect it, because it's made. No, it's the Golden Gate Bridge, مش لأنه made from بس البوابة الذهبية. It's the Golden Gate of San Francisco from the north. That's it. Okay, for example, we have seen these kind of exhaust or the mufflers of the bikes or some of the cars. Now they call it chrome or chromium metal plated, chrome plated, nickel plated. That is in order to prevent corrosion. That's what will happen. If you don't do that, then with time, then it will be corroded. Okay, so that's the end of the first section, which is I think we did answer the question about what undergoes or what happened to the material that undergoes oxidation. That is either gaining of oxygen, losing of hydrogen, or losing of electrons, partially or completely. The reduction is the opposite of that. And also we talked about the corrosion and how to prevent it. What is the corrosion to start with? Why it is accelerated with the presence of salt and water. Okay. So anyways, we'll keep you posted regarding the final exams and third terms. If any changes happen today or tomorrow by the university, either will be informed by us, the UPP, or by the student affairs. But just in case something happen and they will shift the exams earlier, then in that case, all the third midterms, the one that is toward the end of April, will be conducted as you guys requested. Although we said no, but maybe we have to conduct it through with the final exam. And as far as the material, I think we are okay. I mean, what is left is 2 chapters, which means that we need 2 weeks maximum, and we can do that. Maybe 2.5 weeks, and we still have that. Even if they gonna stop on the 15th of April, we should be fine. I mean, I'm talking about chemistry. All right. What about the grades for the chemistry midterm? Who's asking? مين بيسألها؟ فيصل. Inshallah today. Yeah, Faisal. Inshallah. There's some issues with that, but we'll try to fix it before the afternoon, and we will post it in the morning. Okay.